2, 1. Hi, folks. My name is Derek Bigham. I am a developer advocate at AWS, and welcome to another excellent dev webinar series. This is my second in the series. If you have missed the first one, you can catch that on the on-demand site, which I'll share at the end of this talk. Also, if you missed my first talk, you missed some very bad dad jokes. So another reason to check out existing talk on resilient applications. So this talk is a little bit different. Today, I'm going to talk to you about implementing GraphQL API security best practices. So in this talk, I'll go through, let me just show you the slide deck. There we go. So in this talk, I'm going to talk to you about how to best secure and manage your GraphQL APIs that are running on AWS and AWS AppSync. I'm going to make some assumptions for this talk. I'm going to make some assumptions that you're familiar with API options that you have running on AWS. So whether the API is RESTful or in GraphQL, which we'll talk about a lot during this talk, and you have some knowledge of GraphQL and its difference between traditional RESTful APIs. All right. Let's start the slideshow. Okay, so today's agenda. So a quick look at the agenda. I'm going to start with a very quick overview, probably one slide or so, what is AWS AppSync. Then I'm going to dive into how you can actually set up AppSync and use some of its functionality that it has to protect the access to your GraphQL APIs that AppSync runs for you. Before then, we're talking about two areas, networking and observation and observability. And you can look at to increase the availability and the performance of the same APIs. We'll take you through some best practices and you can deploy. And then finally, we'll look at the tools that you can actually use to deploy these capabilities reliably and with confidence into production. So let's jump ahead and get started. So where will we start? So we'll start with AWS AppSync. So if you're not familiar with AWS AppSync, it's a fully managed GraphQL service that runs on AWS. It helps you build scalable applications that you can connect to multiple data sources that are within your AWS account. So if you're familiar with GraphQL, you'll know that GraphQL connects with those data sources via resolvers. So GraphQL presents itself as a single endpoint that clients connect to. And then behind a GraphQL server, you can connect different data sources using resolvers. So AWS AppSync is our managed service. It's also a foundational building block that allows you to build GraphQL APIs for real-time applications that also require offline data access. Many benefits of AppSync, as well as being managed, you don't have to worry about servers or infrastructure to manage your service for your GraphQL API clients, and you can concentrate on supplying a valid GraphQL compliant schema, and you can get started on it right away. So AppSync also helps you connect to the data sources in your account, as I mentioned, and works out of the box with data sources like Amazon DynamoDB, AWS Lambda, and Elasticsearch. So you can easily connect these into your applications. Also, with AppSync, it's a great ability to also connect to AWS services using its inbuilt HTTP resolvers. So one of the resolver types you can define in AppSync is an HTTP resolver, which then gives you the ability, if you think about it, to connect into any data source that is served. It can be hit with a RESTful API. For offline modes that supports AWS AppSync will also allows you to do things like implement complex operations like conflict detection and resolution. So this minimizes obviously the backend code that you have to write to solve these complex problems. And then finally, AppSync also provides a large set of enterprise security features that allow you to set up things like multi-authorization, access control, and it also integrates with WAF, AWS Managed Web Application Firewall, and it provides the monitoring that you need to actually track the performance of your API. So these features are the main features that I'm going to drill into and dive deep on today, and how they can be leveraged to improve that GraphQL API that you want to deploy to production. So let's talk about what a production GraphQL API endpoint looks like. First of all, you need to think about protecting access to that API by making sure that only authorized users have access to the API. Now, while still being able to make sure that you can support multiple access patterns, be flexible, and to cater for different types of users and different types of systems that may have access to the API. While doing that, you also want to grant only the specific access that you need and to be as granular as possible with the access that you provide. And next, you want to protect the availability, making sure that your service is always available while providing the level of service that your customers will expect, which is the service is alive and you're able to work with it. We want to meet our customers' expectations by making sure we're maintaining the uptime of your service, limiting the availability to trusted sources, as well as making sure that bad actors do not impact that service. So you want to be able to block these bad actors, and you also want to be able to protect the performance by making sure you can actually monitor what is going on within your API. You also want to be able to analyze in real time, say make tracing calls for your API, tracing through the different components and hops that are involved in resolving a field, for example, in a GraphQL schema, are all very important things that you need to monitor. And you've all got these things set up and figured out. You want to be able to constantly look to improve this over time. The continual improvement of anything in production is very, very important. So by fine-tuning your resolvers and how they access your different data sources, to always provide best performance is really how you think about continually improving a GraphQL API. And finally, once you've got these best practices and implementation details set up, you want to be able to redeploy these over and over again with confidence and make sure that every time that you deploy an API, you're deploying the best practices into production. So let's start by talking about how to protect access to your API. So AppSync allows you to deploy secure and protected endpoints. So AppSync always requires some type of authorization to get access to the API. It allows you to create a GraphQL endpoint with some type of authorization that you need to provide to get access to it. So in other words, no anonymous public access is allowed. This is very important to understand. There's also always some type of credentials that you need to provide to gain access to that API. So AppSync provides a couple of authorization modes that I'm going to go through next. So depending on the type of application you're building, it could be enterprise, it could be for a startup, and who you want accessing your API, you may want to choose a different authorization mode for each of those use cases. AppSync supports the following modes, which we'll dive deeper on in the next few slides. It supports API keys. It also supports OpenID Connect to OIDC and JWT tokens. It supports Amazon Cognito user pools, which also can serve up JWTs. And finally, it also supports granting authorization based on permissions set up by AWS Identity and Access Management Service, so AWS IAM. So you have the flexibility to choose the right authorization mode that helps with your particular access use case. So as you can see, it's important to understand which authorization mode makes sense in your particular situation. So let's go into a bit more depth on each. The first mode that we'll look at is the humble API key. So this mode allows you to simply specify a header in your AppSync request. So this header is called XAPI key and specifies a value of an API key that you've set up in your AppSync API. So you can for example, go into AppSync console, go into settings and set up an API key and give it a value or use a default that's already provided. This is a fairly simple but efficient mode to use when you're getting started. So use it when you're just getting started with AppSync and you're building out a demo and you're just getting familiar with how it all fits together. This is a great mode to use in those situations. It's also a great mode to use when you're providing what is essentially public APIs, and as such have no specific authorization requirements to implement and no type of granular access control that you need to implement. It's also useful and a good mode to use for business to business or machine to machine use cases. So let's say you have a third party partner and that are accessing your APIs. And you want to provide them different levels of access that you can specify different API keys for each. Or similarly, you have remote servers that are accessing your APIs, and you can securely deliver those API keys to those servers. So API keys always make sense in these situations. Next, we're going to take a look at Cognito User Pools. So Cognito User Pools is a great tool to use if you have an application where users are signing into the app with a user pool and then using JSON Web Tokens or JWTs that they receive from the Cognito User Pool to get access to your API. So a great mode to use if you're an authenticated user in an application, as an example. This mode is also good if you need to connect social identities using Cognito, which is a feature of Cognito User Pools that is a great mode to use. Also, if you're going to build an app that interacts with other AWS services, Cognito User Pools are probably what you want to use, as you can exchange Cognito User Pool generated JWTs for actual AWS credentials, which is very handy. So if you have an application that's also going to interact with something like AWS Amazon S3, then the Cognito User Pool mode is probably what you want to use because of this ability. Additionally, with Cognito Access mode, you can also implement granular access control using directives. So what you can see here, as an example on the left, is a post field in a query type, so a GraphQL query type that's being specifically controlled. What I'm using here is the AWS auth directive to specify which Cognito groups should have access to this post. So in this case, I don't need to write any specific business logic. I just use the directive on the field to specify who has access. And then when I write my resolvers, I can write additional business logic by using the identity of the Cognito user to work out what type of access that user should then have. So this is a nice way of encapsulating that sort of logic. Next, we're going to take a look at OpenID Connect, or OIDC. This is very similar to Cognito User Pools because we're talking about using JWTs to get access again. So ideally, this is good when you have something like an application that already is set up and has a user directory. So you might have an external OIDC identity provider, and you can set that up so AppSync can interact with it and to properly identify and authorize requests with JWTs that have been provided from that OIDC provider. So this works well with apps where you need to authenticate users and where you have an existing user directory. Other things to mention here, there's one difference with Cognito User Pools and OIDC. Is Cognito User Pools can actually be used to exchange AWS credentials. So this is not something that you would be able to implement with the OIDC identity provider. So it's a good mode to use, but just keep in mind that you won't be able to interact directly with other AWS services. However, just like Cognito User Pool, you can implement a very granular access control using the claims that are available in the identity object that is made available to your resolvers in AppSync. In this example, we're implementing something similar to what we had in the previous slide with Cognito, but what we're using to group information into the claims for a specific identity. So like before, we pull up groups, and we know that a lot of groups are bloggers and readers, and we just go through the list of groups to see if they belong to one of these groups. And if they do, you can grant them access. And if they do not belong to any of these groups, you can use the utility method, which is util.unauthorized, to then reject that request, which is very handy. So the last mode I'm going to look at is the AWS Identity and Access Management mode, or IAM. So in this mode, essentially use IAM to write permissions that grant access to AppSync. This is a great mode to use if you have backends running on AWS that are going to access your AppSync API when you're using AWS credentials. And even if you're using, say, IoT systems that are using AWS credentials, you can then use your role that contains the policy to sign your request towards AWS AppSync. And AppSync will then validate that request and make sure you're authorized to access the fields and types that you want to access. And you can get very granular with the permissions here as well. As you can see in this example, IAM policy, you can specify which fields the user of the policy has access to. So this is the mode that I would recommend using if you're accessing from an EC2 instance, because they use instance profiles, or if you're using AWS Lambda function to access the API. So here you can also specify the permissions that the AWS Lambda function should have. So all these modes work well by themselves, but AppSync also has allows you to use one or many of these modes at the same time on a single API, which is a great for application flexibility. This means that you can do multi-authorization on your API and grant different types of access depending on who or what is accessing your API. So you could have, as shown in the diagram here, AppSync system where you have a Lambda function that's running and periodically updating your API, and that Lambda function uses an IAM role to gain access to AppSync. Now on the client side, your users are interacting with the API using Cognito, and maybe you also have an IoT system that then uses AWS permissions as well to gain access. And maybe you also have users that are logging in through your OIDC identity provider and then using the generated JWTs to get access to your AppSync API. So you can specify additional providers as needed. You select the default mode and then you specify additional providers. So you can get pretty granular as you specify which types of mode has access to different fields. This multi-authorization setup is pretty powerful and well worth checking out. So that's authentication and authorization strategies that you can adopt to protect your API. So next I'm going to take a look at protecting the availability of your API. As with auth, we're talking about making sure that your API provides the experience that your customers are expecting from it. So it's always available. So with AppSync, it provides DDoS protection for every API that you configure. This means that it's built in to withstand attacks and can scale to absorb those attacks. Additionally, it also integrates with AWS WAF to provide additional firewall rule types of functionality to your API. With AWS WAF, you can actually protect against exploits that impact security and availability of your API. And the great thing about AWS WAF is it's really easy to configure, and that's what I'm going to go into next and show you a bit more detail on that. So if you haven't used it before, AWS WAF, or a web application firewall, is a web application firewall that's managed and runs on AWS. It integrates with services like AWS Application Load Balancer, Amazon CloudFront, API Gateway, and of course AWS AppSync. Again, like AppSync, it's a managed service, so there's no infrastructure for you to manage. There's really a very low operational overhead as you simply use the rules that you write yourself, or you can use managed rules that are provided by AWS. These are rules that are updated automatically to protect you against the most common threats, like cross-site scripting detection, SQL injection detection, as examples. It's highly customizable, so you can use your own rules, or you can also use third-party rules that you can find in the AWS Marketplace. So WAF integration really opens up the door for a lot of additional security and protection of your API. Some of the use cases where WAF could be used with AWS AppSync, we'll go into more detail in this section. You can protect your API against flooding and being overwhelmed. You can turn off introspection in situations where you just don't need it. You can support B2B APIs using API keys that we discussed earlier. And you can make sure that your different partners or third-party partners that have those keys do not overwhelm the actual API with requests. And finally, you can also limit access to Amazon VPC resources only. So I'm going to show you how to do these in the next couple of slides. So let's talk about flooding. So protecting against flooding is when we can use WAF as an access control list that you can configure inside AWS. So you can do this by setting up a rule that will actually throttle requests that come from individual IPs. So if you've exceeded a certain rate per 5 minutes segments, as an example, that will then start to throttle. This is a good rule, so you can set up to actually protect against flooding, so the bad actors that try to overwhelm your API. Next, you can turn off introspection of your schema. So introspection of schema is a benefit of GraphQL, but that functionality may not be applicable in production. As an example, you don't want it may only be you may only want it in development. So the introspection itself is a special query in GraphQL that allows you to discover the schema. So you can see how that's really important in development, but may not be so important in production. And so you may want to turn that off. So you can set up a rule that blocks any request that contains the special underscore schema request. That way, introspection will be turned off, and that only impacts introspection queries, and the rest-of queries are not impacted, which is good to know. Next, you can support B2B APIs using the API key. So we're looking at some of the throttling rules that can be set up, but you can also set them up in different ways. Rather than IP addresses, you can use different API keys that you may have set up for your API. So if you've set up different API keys for different businesses that you're working with, you can throttle on those. You can also set different throttling rules for different APIs. So that's also a way of configuring different levels of access and different throttling rules for those APIs. And then finally, you can greenlist access to your VPC. So you may have a situation where you have a VPC, you have an AppSync API, and now you only want resources from your VPC, maybe your EC2 instances, or you only want those EC2 instances or requests that are originating from inside the VPC to have access to the API. What you can do is set up a WAF in front of AWS AppSync with a default rule that blocks all incoming traffic. Then you can set up one rule that allows traffic that comes from your NAT gateway, Elastic IP addresses. This way, you're blocking everything else, and you essentially have a private API that's only accessible from your VPC. So that's how you can protect access to your API. Next, we're going to take a look at protecting performance. First thing you want to think about when you talk about protecting the performance of your API is making sure that you can actually monitor that performance. Therefore, making sure you understand what's going on with the performance and with your API. AppSync allows you to do that by providing CloudWatch metrics. So by default, you can monitor the latency of your API, and you can also monitor the number of requests that are coming into your API, number of 400 errors and number of 500 errors. AppSync also integrates with CloudWatch logs. So this allows you to use these logs to actually gain further insight into what is going on with your API. So with CloudWatch logs, you can do two things. You can log insights into some query of your logs to figure out what's going on. For example, you can look at the tracing logs to understand the latency that your different fields and resolvers are experiencing. And if you find that insightful, you can then choose to create metric filters to create specific latency metrics for fields that you want to monitor closely. Now, once you've created those metrics, you can also set up alarms against them. So you can be notified if some of your field resolvers are taking more than expected to resolve requests, as an example. And then based on those alarms, you may choose to take different action. Maybe you want to introduce something like a cache, or maybe there's some fine tuning that you need to perform for your resolvers to improve their performance. That's monitoring and how you can use it to improve your API. But sometimes you also need to do some real-time tracing of those APIs to find out what's going on. You can do that with AWS X-Ray, which also integrates with AWS AppSync. AWS X-Ray provides end-to-end tracing in near real time, so it allows you to see how the different components that make up the call chain of your AppSync requests behave. Now, knowing GraphQL and resolvers and the number of data sources you can have, this becomes really important. It's also a great visual tool, so you can use to identify performance bottlenecks. And you can see which components in the chain are actually contributing the most to latency. So in this example, you have a request that is accessing both Lambda and DynamoDB, and you can then work out which of these components is contributing the most to latency, and you can take steps to fine-tune them. Then finally, we can fine-tune or optimize out our API with caching. So AppSync does provide a cache that sits between your API and your back-end resources. So if you run into a situation where you want to provide faster response times for some of those requests, you can introduce this cache. As it's fully managed, you can set it up for full API caching, and at that point, all requests will be cached, so providing that millisecond type of response time for all of your requests. Or you can set up a per resolver caching. You may have some resolvers that you do not want to cache as the data changes rapidly, but you may also have resolvers where you know the data does not change that much. Maybe it's a read-heavy system and you want to put a cache in front of one of your queries, so you can turn that on. Finally, you can turn on encryption as well to protect your data, both at rest and in transit. So now let's see if we can put all of that we've learned into action in a production system. So far, we've looked at protecting your accessibility, protecting the availability, and protecting the performance. These are different components that can really help you build APIs and get them ready for production. And when you really put it all together, you end up with an infrastructure that you can easily deploy on AWS. So AppSync integrating with these different services to build infrastructure that's ready for deployment. So here you have AppSync integrating with X-Ray and Amazon CloudWatch, sending logs and then creating latency alarms. AppSync also interacting with different backends like DynamoDB and AWS Lambda, and needed to introducing AppSync Cache to improve the latency and to resolve time. Next, we have AppSync integrating with AWS WAF, where we have WAF protecting your AppSync API from flood protection, limiting and blocking introspection queries. This is something that you can build with AppSync and with the different services that interact with AppSync, and it's something that you can deploy fairly easily with the AWS CDK. So let's look at a demo and see how we go about deploying this application. Now, if you haven't come across CDK before, it's a set of tools that allows you to build stacks and infrastructure using infrastructure as code. So you can deploy reliably on AWS into your account, and you can deploy multiple times over time reliably as well. So what I'm going to do is jump into a demo and show you how you can actually build this infrastructure that I've just talked about using the CDK. Now let's bring in the demo full screen so you can see it. So there we go. So here is my Visual Studio Code, and here I've got a CDK project. So it's with the CDK, we have a number of stack items, and we have a schema. So if you look at the GraphQL schema that I have here, I've got a number of, I've got to-dos, I've got user pools, and I've got an API key, query. I've got some queries, get to do, list to do, some mutations, create to do, update to do, and some mutations. So it's a fairly standard schema. And then if I look inside the stack, I've got a number of data sources that I'm defining, all in the CDK. So I've got a DynamoDB table called to-dos that I defined, and a Lambda function. Now, look, I'm also doing grants on the Lambda function to read data. And that's all defined in CDK. So next I've defined a user pool. So here's my Cognito user pool, which I am defining here. This user pool then will use two authorization keys. So it's got authorization type of API key, and it's also got the authorization type of user pool. So both of those authorization configs I pass in when I'm creating my GraphQL API. So we just close this up a bit so I can see that's my user pool defined, and then add any further things that I need to. Again, here, just showing you how to add the different authorization types. And then in my to-do type itself, you can see I'm using, I'm annotating it with the two user pool names, so Cognito user pool and the AWS API key. So it will then apply access control into those fields, so that, and it will also apply access control into those actions. So the query action can only be used by AWS Cognito user pool. So let's test that out. So here I am in the AppSync console. The minute I'm logged into the Cognito user pool. So I can log out if I want, but I'm going to do some testing. So the first thing I'm going to run one of these queries. So get to do will return the ID of the to do, and list to dos. I'll get it to return an ID as well. So if I run list to dos, you can see that there's an error because list to dos is not something that I'm authorized to do inside the Cognito user pool, because I haven't used that, added that access control of Cognito user pool for list to dos. I only added it for get to do. So that's, you can see how granular that access control is. So now that's access control. The next bit I'm going to set up is my WAF. So define my WAF config here in the CDK. And inside that, I'm actually creating a new stack for WAF, which I'm going to jump into now. And inside WAF, I'm going to set, I can pass in a comma delimited list of allowed IPs. So this allows us to block or only open the API to these allowed IP. So remember, if I've got the service sharing it with other businesses or B2B, next I can set up where the CloudWatch metrics are going to. So I'm setting up a metric name, and I'm also adding in some WAF rules. So I've got a flood protection rule, which is going if that IP address that has the request is not in my list, I will limit it to 2,000, and then and that's the throttle once I hit that limit. That's how I add flood protection to WAF, so it will be in front of my AppSync API. So all this code will be in my GitHub repo, and I'll show you where it is later. So another thing I can restrict is the API key, so only for known API keys. So here is what I'm doing. I'm introspecting the XAPI key header. I'm making sure that it is in one of my known APIs keys. And if it's not, I won't allow it. So just specifying that. It's a field to match. And that's what that is doing there. It's very, very cool, because then that completely integrates what my API keys are in the AppSync service and what is allowed through WAF. Let's we can actually test that out as well. Let's see how after we've deployed it, how we can test that out. So we can test it out by using curl. So if I curl this from this machine, so I'm doing a post. So all API queries are posts. Sorry, GraphQL queries are posts. I'm passing the API key in the header, and I'm doing list to-dos. So if I enter that, this machine here, the IP address has been greenlisted. So it should be allowed, and I should get a return. And there we go. So I get a return of all the IDs from list to-dos, which is cool. So that operates as expected. However, if I change the API key authorization mode in the console, this IP address hasn't been greenlisted. So if I then try and do the list to-dos query, I should then be blocked by WAF. If I run this one using the API key from the service, this should be then blocked. So there we are. So we've got WAF forbidden exception because this IP that the query is coming from is not one of my greenlist IP addresses. So that's how to implement WAF rules CDK that will go in front of your AppSync API. The next thing I'm going to do is show you how to configure CloudWatch. So I've got a CloudWatch config here that will be taking into it the API name and all the fields that I've got. So this will show you how to use these fields to give you granular logging. So again, the CWP config is another stack that I've created inside CDK. You just jump in there, and you'll see that I've created a log group, and for every field and field type, I can have a metric for the API. So I pass in the API IDs, a metric name, and a field name as the metric name. So then I can have a pattern that makes complete sense to my API, and that is the type. So not only the field name, but actual type of that resolver. And so anything that's happening inside my API will go to the right log group, and then I can search it if I'm experiencing issues or want to create alarms. So here's one of the alarm that I can create. So this is alarm latency value. So if the threshold is broken, so 300 milliseconds is broken, then it will raise the alarm and tell me that my latency of one of my resolvers is too high. So again, it's a nice way of encapsulating your CloudWatch metrics and alarms inside the CDK. And the way to build out reusable infrastructure as code that you can do to deploy AppSync across a number of environments. So that's the code for AppSync. So what's next? What else can I show you? Let's make this big again. So here is the code, the actual code for that demo. So it's in my GitHub repo. So feel free to pull it down and have a play with it. It will deploy into your AWS account, and you can see and use it to set up your own CDK stack to deploy your AWS AppSync instance and the various other services that I've discussed that will enable you to improve your security, observability, monitoring, and performance of your GraphQL API in production. So there's also, as well as the code, there's some resources that are worth looking at. So we've got the main AppSync website. We've got the AppSync community on GitHub that you can look at. We've got our mobile blog for AppSync and various other resources. So as I mentioned at the start, this developer webinar is a series that you can register for and get notifications on when it's going to happen, and also look at the on-demand content after it happens. We're also taking questions at the end, so if you have any questions on this talk, I'll be here to answer it, and yeah, just ask whatever you want. We also have an upcoming conference called the Innovate Conference over 2 days. It'll we take you through how to build and deploy applications on AWS, so you can register for that here as well. As with anything, feedback's important, so please, if you enjoyed the talk or if you didn't, please reply, add feedback for improvement opportunities. So that's it. So thanks for listening to me tell you about best practices and approaches of securing and observing your GraphQL API using AWS AppSync. So thank you very much, and I'll see you next time.